In this video, we talk about errors in hypothesis testing. So any decision that we make based on a hypothesis test, it could be incorrect, right? And the reason is because we are only using sample data to make some conclusion about a population parameter, right? And so sample data only has partial information, right? And so you're making a decision about the entire population only from the partial information. The only way to be totally correct, right, would be to go and take data from the entire population. And again, that's not really feasible in a lot of situations, okay? We can't do that because too much time, too much money, right, involved, and other reasons as well, okay? So, but the thing to keep in mind is that anytime, right, you make this, do these hypothesis tests, right, you're going to have some uh, some error, right, involved. It's possible to make errors, okay? All right, and so in this video, we're just going to talk about the different types of errors that we'll have, and classify them. Okay, so first thing that we need to do is to kind of recap what we've said so far in the previous videos about hypothesis testing, right? You're going to have an experiment or a survey or something that you're setting up, right? And then you are going to make a null and alternative hypothesis, right? And then you're going to perform your test, right, and make some calculations, and we will show you how to make those calculations in section 9.3, okay? So don't worry too much about how these calculations are made. Again, we're just kind of talking about the framework of the test and how they would run before we start getting into the tiny details about what to do during these tests, okay? All right, so we've got our null hypothesis. We've got our alternative hypothesis. And then the results, like we talked about in the previous video, we're either going to reject the null hypothesis or we are going to not reject the null hypothesis. All right, so those are the two points that we could come to once we run through this hypothesis testing. So in this little chart here below, I have those two possibilities, right? The result of doing a hypothesis test, we're either going to reject the null hypothesis or do not reject the null hypothesis, okay? All right, so the null hypothesis, right? Remember, that's a statement about the population mean, what it's equal to, right? We talked about that in previous videos. So that statement about the null hypothesis about the population mean, right, could be either be true or it could be false, right? And so those are reflected here in this table. So those are the two possibilities, right, for the truth value of the null hypothesis. So that gives us four possibilities here, right? The result of our test is either rejecting or not rejecting, and the actual status, right, of the null hypothesis, it's either true or false, okay? And so what we would like to have happen, right, is that when the null hypothesis is true, right, we would want it that we do not reject that and say, no, it's not true, right? The null hypothesis is not true. It's more the alternative hypothesis is now the correct situation, okay? So if the null hypothesis is true, what we want, right, is to not reject it because it's the truth, okay? On the other hand, when the null hypothesis is false, what we would like to have happen every single time, right, is that we would reject the null hypothesis, right? Why? Because it's false, right? It's not true, and the alternative hypothesis is the one that's more likely to be true, right? Okay. And if you think about the way that the alternative and null hypotheses are set up, right? With the alternative hypothesis, it's that there's the three possibilities. It's different, right, from whatever the null hypothesis says it is, right? That's when it's not equal. So in that case, the null hypothesis is it's equal. The alternative is it's not equal. That's directly opposite of each other, right? And then with the other types of alternative, right, it's greater than. So again, it can't be, the same equal to a number, and then also at the same time greater than it, right? Those are mutually exclusive, and same thing for the less than. So if you think about it, in all three situations of alternative hypothesis we have, right, it's going to be mutually exclusive with the null hypothesis. In other words, they can't both happen at the same time. Okay, so again, the correct decisions are when what we would like to have happen every 100% of the time, right, is that if the null hypothesis is true, we would fail to reject it. If it's false, then we would reject it. Of course, right, since we are operating on only partial information, that's not going to be the case 100% of the time, and it is possible, right, to make errors. You just get there's always going to be a sampling error, right? And so the two types of errors are classified as a type 1 error and a type 2 error. So a type 1 error is made when you have a true null hypothesis and you reject it, right? So the null hypothesis is true, but we say based on our sample, right, we reject that in favor of the alternative hypothesis. And that's not a, oops, sorry, it's down here, right? The null hypothesis is true. We reject the null hypothesis when it's in fact true. We don't, that's an error, right? We wouldn't conclude that the alternative hypothesis is the correct one because of the fact, well, that's the opposite of the null, and the null is true in this case. So when we reject a true null hypothesis, right, that is called a type 1 error. The other situation, right, is when we have a false null hypothesis, right? So the null hypothesis is not true, and then we do not reject the null hypothesis. So we actually, in reality, have a false null hypothesis, right? And we do our analyzing the data, the sample data, right? And that leads to us not rejecting, right, the null hypothesis in favor of the alternative hypothesis when the null hypothesis is false. Okay, so those are the two types of errors that can be made. And again, it's not really possible to avoid those errors, but we will see that we will be able to get a number, right, associated with some probabilities that we make these errors. Okay. All right. So let's take a look at the following example. In the following example, we talk about problem 9.24 from our book. It says, refer to exercise 916, explain what each of the following would mean: a type 1 error, a type 2, a correct decision. And so let's take a look back at example 916. And we did work 916 in a previous problem. This is about the gray seals, right, and their lactation period. So just cut to the chase here, right? In that previous video, we looked at, it says the average lactation period of all earless seals is 23 days. A hypothesis test is to be performed to decide whether the mean lactation period of gray seals differs from 23 days, all right? So the alternative hypothesis was that the mean was not equal to 23. That comes from this sentence here, right, where it says the mean lactation period of gray seals differs from 23 days. That's one of those key words, right, that tells you which of the three alternative hypotheses it was. And then the null hypothesis would be that the mean is equal to 23. Okay, so let's take a look and get to where we can write on here. All right, so just remember what the two errors are, right? A type 1 is when we reject a true null hypothesis, okay? And a type 2 is when we do not reject. The false null hypothesis. Okay. Okay, so they want to know what, in part A, they want to know what a type error would look like, right? So a type 1 error would be that the null hypothesis is true, right? So mu does in fact equal 23, right? But we reject. The null hypothesis, okay? And part B, right, would be they want to know what would a type 2 error look like for this particular experiment. So a type 2 error, right, would mean that it is not true, right? The null hypothesis is false, right? So that means that mu is not equal to 23. All right, so this is the truth. But then we turn around and we fail to reject or do not reject. The null hypothesis. Okay, so that's what a type 2 error would look like. All right, and then C, they want to know what a correct decision would look like. Well, there's two ways, right, that we could have a correct decision. So the first way would be mu equals 23 is the truth, right? The mean is actually 23. Okay, and so that is our null hypothesis, right? It's true. And then we do not reject. Right? We get the truth to the truth, which is what we want. And that is that it's the null hypothesis. The mean is 23. The other situation, right, is that the way that we could make a correct decision would be if the null hypothesis is false, right? If the truth really is that mu is not equal to 23, and we reject the null hypothesis. Okay. Okay, so the null hypothesis is false, and we rejected it, which is, again, correct, right? Correct decision. All right, next up is part D. All right, in part D, they say, now suppose the results of carrying out the hypothesis test lead to a rejection of the null hypothesis. All right. So they're saying, hey, the hypothesis test was done. It led to this conclusion. We rejected the null hypothesis. Okay. All right, it says classify what that conclusion by error type or as a correct decision if in fact the mean lactation period of gray seals equals 23 days. All right, so they're saying, hey, this is the truth and we did this. So is that an error? If so, which type? Or is it a correct decision? Okay, is what they're asking. All right, so for part D, they are saying, hey, this is the truth. The mean actually is 23 days. So we can see, right, compare that to our null hypothesis. Our null hypothesis was that the mean equals 23 days, right? So that means our null hypothesis is true, right? So in part D, right, our null hypothesis was true. And what did we do? They say that we rejected it. All right, so our null hypothesis was true. We rejected the null hypothesis, all right? And that's a mistake, right? Because if it's true, we don't want to reject it. We want the truth, okay? So that's an error. What type is it, right? Well, it's a type 1. A type 1 is when you reject a null hypothesis that's true. So this is a type 1 error. All right, part E. Okay, in part E, right, they say differs from 23 days. So they are saying, right, that this is the truth, right? The actual truth is that the mean, right, differs from 23 days, all right? So if we look at that in the context of our null hypothesis, right, our null hypothesis is the opposite of that. So if this is the truth, well, then our null hypothesis is false, right? So our null hypothesis is false. And then here they say your test leads to the rejection of the null hypothesis. Okay? So that is a correct decision. It was false. We rejected it. So this is a correct decision. Okay. Okay, so that's it for this video. In the next video, we will work another problem exactly like this.